Now I'll show you how to solve linear regression or least square regression by using MATLAB. So I'm considering same problem what I did last time. I solved this problem by hand calculation as well as in Excel. Now I'll show you how to solve in MATLAB. So we know for least square technique we have to get one best fit linear equation, and by using data we have to get that slope and intercept, so that if we get the slope and intercept, so we can easily get that linear equation. So for that for that we need to form the matrix. In the matrix we need the data, okay, and if we need the data and we'll form that X is equal to B. Obviously we need that A matrix and B matrix. Then if we solve X is equal to A inverse B, then we will get that slope and intercept of the equation, and if we get the slope and intercept, so we can easily get the best fit linear equation. Now how to solve in MATLAB. Now here T and P data are given. Okay, so we know from this the T and P data we have to fit that the linear equation. So here ideal gas law, we know that PV is equal to nRT, P is equal to nR by V into T, and that we fit as a Yp is equal to A1x and A0. So now here my target is we have to calculate A1 and A0 by using MATLAB. Okay, so now here Yp is a P and A1 is nothing but nR by V. Okay, and T is as a X. Okay, now how to solve in MATLAB. Okay, so this is editor. Okay, so first in editor I have to write CLC. CLC means clear skin and clear all. If there is any variable is refer before, means if any variable used before, so that will clear the variable. Clear all. Okay, so that in every code we write that things to clear skin as well as clear the variable. Now I am taking the data. So T is equal to, that is given. Okay, T are given, T's data is given, that is minus 40, 0, 40, 80, 120, 160. Okay, so that is we are creating the matrix, that is minus 40, 0, 40, 80, 120, and then 160. Okay, so that I am creating matrix. So that is T in degree centigrade. Okay, if we run that, okay, we'll get that T data. Okay, so that is T data. Now I have to take that P data. So before that I'm converting T in degree centigrade to T Kelvin, T plus 273. So that is T in Kelvin. Okay, now I'm going to take that P data. P data are like 6900, then 8100, 9350, then 10500, then 11700, 12800. So that is given, the data are given, that is Newton per meter square. Meter square. So that data are given. When if we run, so you can see, so these data are given. Okay, so even if we go to the PPT, so these are the data T and P. Okay, so that data are actually called that observed data, right? So observed data, we can say that observed data. Now here, so X is nothing but T data. Okay, so that is independent variable, I can say independent variable. Okay, and then y data is nothing, y datas are nothing but p datas. Okay, so that is dependent variable. Yeah. Okay, so now we'll get that. So here, so x and y data are given 1 2 3 4 5 6 1 2 3 4 5 6. Okay, so now first, how many data points are there? So number of data points, number of data points, that we can calculate. N is equal to, so we need n, right? Then we can easily calculate n. So that one MATLAB command is there. So length, leng, length of x data or y data you can put. So that will give the length. How many data are given? Data are there. Okay, so that is numbers. Data points is 6. Okay, then calculate the sum, right? Calculate sum. Okay, calculate sums, yeah, because we need that summation, right? So if we go through this, so we need all this summation, right? So we have to calculate all this. Sum. Okay, so we can calculate that everything we can get that. Okay, if we do that, I'm just putting here paste. So sum of x, so nothing but sum of x, sum underscore y, sum of y, sum x square, sum of x dot into square. Okay, so the sum x square, sum of this. Now here I'm forming the matrix. So matrix formation. Matrix formation. So that will be A is equal to what? N. Okay, so N. Okay, then sum of x, then second row sum of x, and then sum of x square. So this is the matrix. Okay, so again, if we run that, we will get that matrix, right? So this is matrix. So again, if we go to that PPT, okay, so here we calculate that matrix, right? So this one 619, so that we are calculating here. Okay, next we have to form that bit matrix formation, B matrix. So B will be, so that is sum of y. Okay, and then second row is sum of xy. Okay, sum of xy. So that is the B matrix. And now we can calculate that unknown. So I can tell that x, I am already taking x, so we can write xl. So that is unknown. Okay, so xl. So that inverse of A inverse of A. So that is in MATLAB, in the inbuilt function inverse, A inverse into B. If we do that, if we run the program, we'll get, so A inverse B, so that is 29.6786. Okay, so we did something wrong, maybe sum y, sum of xy. So here 69008100929350. So here the data is wrong, 9350. If we do that, ultimately we'll get, okay, so that is 32.488, 19.607. We'll get that. Now, so what will be the slope? So calculate the coefficient. So you can write that, I can put it here. Already I did that. Okay, so if I put that, so that will be the coefficient. So calculate the coefficient, slope and intercept. So that will get that. Okay, so okay, slope we can run, and then we can get slope is 29.607, and intercept is 32.488, right? So now if we display the equation, so equation will be what? Like that. Equation will be like that. Okay, so display the equation. So I can put all this already there. Already I have written that. Okay, so fprint I am using. So if we run that, we'll get that. Okay, so this is the fprint comment, right? I can make smaller. Okay, so this is the fprint comment. Okay, so from that fprint comment we can easily get that. Okay, so the equation of line is y is equal to 32.49 plus 19.61x. Okay, so by using MATLAB we got that line of equation of line. Okay, equation of the line is y is equal to 32.49 plus 29.61x. okay, now we can use polyfit. Okay, so by using polyfit also we can get that. Okay, so here that we can take that we can use. Okay, so by using polyfit also we can get the same thing. Okay, so now using polyfit. Okay, so here a is equal to, now I'm taking polyfit inbuilt function, polyfit inbuilt function. Now you have to give that x and y data, x comma y data, and then as we are taking the linear, we are doing we are fitting the linear fit, means we want to get that the linear equation. So here the degree of the equation is 1. Okay, so that is degree of equation. Okay, so it means I can write that. That will be good if we write. So we can display here. So using polyfit for linear equation, the degree is 1. Now we can get the coefficient. If we run that, we will get same coefficient. See, coefficient is 29.607 and 32.488. Okay, so now we can also write same thing here, that we can paste it here. So a1 is a1 and a0 is a2. Now line will be this. See that again y is equal to 29.6071 plus 32.4881. So that we are getting from polyfit. Okay, now we know so many things are there. So here if we write that, we know. Okay, so these data are given, we can write that. So p is equal to, I am displaying that p is equal to nr by t. So nr by v is nothing but a1. So if we run that, we'll get that. So p is equal to nr by v by t. So nr by v is equal to 29.6071. So from that, okay, and data given. Okay, so data given, that is we can already do that. So I already write the equation. So you can and copy and then I paste it. Okay, so that here data given, mass of nitrogen is given, volume is given, molecular weight of nitrogen is 28 gram per gram mole. Okay, fprint, by using fprint, the number of mole of nitrogen, we can easily do that. Okay, so n will be 1 into 1000 by 18. Okay, so now if we run that, we'll get that all this. So mass of nitrogen 1 kg, volume of nitrogen 10 meter cube, molecular weight of nitrogen 20 gram per 1 gram mole. So number of mole of nitrogen is 30.714. R will be D into N into X 29.6071. So R will be 8.2901 meter cube Newton per meter square per mole Kelvin. So that R we can easily calculate by using MATLAB. So now here I am showing two ways. One is MATLAB as well as polyfit. Now in both cases, so R will be same. So if you take that slope and intercept, and if you take same thing, I mean, already we got right a1 and a0 from the polyfit, as well as a0 slope and intercept from that MATLAB. We are getting same thing. So ultimately we will get same result, means same R will be 8.2900 meter cube Newton per meter square mole Kelvin. Okay, now we already know R, so we can easily calculate in particular temperature what will be the pressure. Now temperature is particular temperature T given Tg. I can write Tg is equal to 100 plus 273, that is Kelvin, and P will be, okay, so P calculated will be, so N into R into Tg by V. If we do that, so we can easily calculate. So V is here. What is the V? V is not given, so we can write V is 10. So if we do that, so EC will be 1.10343. So that is nearly here. Okay, so that is we can calculate that DC. Okay, now we can plot that. We can plot everything. So that plot command we can use. So here we can do that everything. We can plot all this data. One is MATLAB as well as polyfit. So for that I have written code. So this the data point, original data point. Okay, original data point. So plot x, y, original data point. Then this is the data point fitted line like MATLAB, and this is the fitted line by polyfit. We do that. If we run, so first that observed data x is x, y, hold on, and then plot t intercept plot plus slope x, that red color, and hold on again. So that is polyfit. Again we got that a0 plus a1t. Okay, so a1t or x will get same thing, or here also we can put as a x. Okay, if we run that, we will get same result. Plot command. Okay, so here that should be comment line. If we run that, we'll get. So this is that graph, nice graph, polyfit, everything. So this is the code. We can use that code and we will get everything. That's it. So now I'll show you how to do in MATLAB, and I'm showing how to plot everything. That's it. Thank you.